Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in bonus weeks, and this would be week number 63. In this week, in this lesson, we are going to talk about user interface stuff and see these cool graphs that I'm displaying here for a particular host, both response time, availability, and summary for response time and availability. We're going to talk about how you render this in the front end. So we're going to be looking at the JavaScript code and the framework code and the HTML code that I used in order to create this. So this is a front end, a user interface discussion. What we'll be talking about is what the user interface is, how it works. You can see down here that there's actually two web services running, as we've mentioned before. If you need to review things, you can go back to where we've talked about the user interface. You can also look at the original Quokka implementation and the Quokka walkthrough. But there are two web services. One is serving up the framework for these pages. One is actively giving you the data that comes from our database. So we will be looking at that. We'll be walking through the code to see how we do host status, how we get the data, how we render the data, how we create the graphs, etc. So there's a lot of stuff. This is a long lesson. My apologies, but even with this long lesson, I am sort of just scratching the surface. Oh, and by the way, I will be giving you information about JavaScript, so you'll learn a little bit about how JavaScript works with their curly braces and the way that they do things that's a little bit different than Python. Anyway, that's what we're going to talk about, so let's get started. Okay, so let's talk about this Quokka Prime user interface. Now, we've looked at this before. I've had a lesson on this before, so I'm not going to go into all of the detail that I've already gone through on the lesson, but it's always useful to have a sort of an overview to refresh our memory about what is going on. So we will spend a little bit of time doing that. But first, I want us to be familiar with what the user interface brings to the table. Now, right now, what I'm looking at is the devices table. This is showing me the devices that I've discovered, and I'm putting that in air quotes. I didn't really discover them. I have configuration, the YAML file that points at these, but this is my devices information and my devices table. I have a hosts table, and my hosts are automatically discovered by my Python application, and I go out and I learn the IP address, the host name and MAC address, and the open ports for every one of these hosts. So this is a nice table. You see I can go forward in the table, I can go back to get to the beginning of the table. I can sort based on things like open ports, last heard, etc. And that's true of all of the tables. So that's another example of a table, host table. Services, another thing that I monitor the availability and response time for, as well as whether it's meeting these SLA agreements that you'll see that I've implemented and printed out appropriately here. So you can see that here is another table, and of course packet capture. When I prepared for doing this just a moment ago, I realized that my trimming of the database is not trimming the packet capture table. At least it's not trimming it correctly. So if you recall in our last episode, our last lesson, we talked about trimming the database, and I don't seem to be doing that correctly because these are from over a month ago. So, but anyway, I digress. Tables right here. Now, once we go from tables to something else, it gets a little bit more interesting. So, for example, if I wanted to come to all of these, I have a button over here that says display time series for service. I know that's kind of small, the pop-up tooltip thing, but that is what that graph represents. I've implemented that button for everything, for devices, hosts, and for services as well. If I was to click on this, then what comes up is a nice graph, and the graph shows the response time and availability for the current last 24 readings that I have, and then it goes back and it gets the last 24 readings which are on an hourly basis. So this is a summary. Now you'll see this in these particular screens that I'll be working with today. You'll see that it looks like I don't have any data from about the middle or towards halfway through Friday to Saturday, as well as up until just recently here on Wednesday when I'm taping this. And that's exactly right, because I actually left my wife and I to go visit our son and his wife, who had a child recently. So my first grandchild, went and visited them. So I was gone the entire weekend as well as the beginning of the week. So I just got back. Anyway, if you see that, that's why there's nothing here. I haven't been running my software to gather this information. So this is what the user interface looks like. And the next thing that we're going to do is we're going to refresh our memories on how the whole user interface thing works. So let's look at the high-level architecture of how the user interface works. Now in the picture, when I was describing the user interface, I have this picture, and I will have shown you this in the lesson where we talked about the user interface. This isn't the only picture that I showed. This picture is a little bit misleading. The reason it's misleading is you'd think that all of the user interface comes from our REST Flask application. And while the data definitely comes from there, the entire user interface is made up not only of that, but also, like when you look at this table, there's the framework for this table, and there's the stuff that goes along here at the top, and there's grids that make up the information that we are looking at here, and there's different other components, etc. So not only is there the actual data that we may be looking at from here, but there's also the structure. And in reality, what it looks like is not just this, but it looks like, and this is an old picture that I used in my original description of Quokka. If you are interested in going through the Quokka walkthrough, probably if you're with me at this point in time and you haven't done that, I would say that you have graduated enough to understand that you may be interested in going through that stuff. But for right here, this is the picture, the slide that I created to describe how the user interface works. And I've tried to articulate in a couple of words what I just described when I was waving my mouse cursor around these screens. And that is that the static data, that would be the stuff that makes up the table, the external stuff, but not the internal data itself, that all comes from something over here that is actually a web application that is running, and it is running on Node.js. We are using the React framework from Facebook. We're using the Material UI look and feel from Google, and some other stuff that we will look at a little bit later. That is all what's making up the bulk of this table in terms of its structure and where everything goes. The actual data that goes inside here, in other words, the hosts that it's been discovering and the status of services and devices, etc., that actually comes from our Flask service. So I want to make sure everybody's aware of that distinction. There's actually two different web servers going on in our situation. One is providing and delivering the framework for the pages and how all that works, and that includes all the stuff I mentioned. And then there's the thing that we built, which is Flask, which is delivering just the data that comes generally from the database, etc. So I want to make sure you have a solid understanding of that general architectural overview. Now, it occurs to me as we go through this that you might benefit from seeing how I'm actually running all of this stuff. And so let me demonstrate that to you. Right here, I have a terminal window, and I've separated it into multiple tabs. You will have seen me in the past having separate windows for the server, separate window for the monitors, separate window for the user interface, and I may have had workers running. I don't right now, so you may have seen me with multiple windows. You can also just create other tabs by clicking on this button and have everything running in one place. So what I'm going to do here is I'm going to actually show you how I run everything. So I'm going to do a Control C and hope that this shuts down my service that's running. If you recall, I do have a thread running in the background, so it's going to shut down my DB hourly task thread. That has shut down successfully. Now if these are running, you're going to see a bunch of errors and it's screaming and getting all excited because it can't communicate with the server. That's fine. Now in order to shut down these monitors, it's more complicated than doing Control C. I actually need to have a script that runs and shuts things down for me. And if I've typed in the password correctly, because some of these things run with sudo, then this will have shut down the monitors. I'll come back here in a second and we will see what's going on. Now if I were to try to show you what the screen looked like, I could still get information, in other words the framework for this, but I can't get the actual data because the data, I've shut it down. Remember, this is the Flask service that is getting all of these GET calls to get the services and to get devices, etc. It's not able to do that now, so when I go through here and I try to display these things, it's not going to show anything because it can't get the data because I've shut down my Quokka Prime Flask service. I've also shut down the monitors. That's going to cause it to be the case that I don't have updated data, so I'm not getting my minute-by-minute data. Now I've not shut this down. This is actually the user interface, as you can probably infer from the fact that my directory is Quokka Prime /UI. I am going to do Control C here, and now I've killed it. Now the thing is, and this is a little bit interesting, I can actually, it has loaded, this is a little bit of how software in the front end works. It's loaded all of the JavaScript code so that it can render the pages for this successfully. In fact, if I were to have the service running, why don't I just do this just for kicks and we'll see if this actually works. I don't know that I've tried to do this. Now I'm going to come here and I'm going to go to devices, and you can see I'm actually getting data and I'm getting hosts and I'm getting services. And now you may be saying to me, how can that be? You've killed this Node.js thing. Remember this thing right here. How is that working? So pay careful attention. The way that it's working is this. When the application starts, in other words, when Quokka starts, it loads all of the JavaScript, HTML, and CSS code that's necessary to display the pages that we were looking at. So all of that code is actually inside this browser. So the browser's memory, you may see that your Chrome browser or whatever browser you're using, Safari, whatever, Microsoft Edge, whatever you're using, you may see memory on your laptop or your VM go up when you run a bunch of windows. That's because it loads all of the code for displaying this stuff. So all of my user interface code is running here, even though this is shut down. Now, if I were to come in here and say, hey, I want you to reload everything, you see I'm going to click on this button, it's going to go out and it's going to say, up, I can't get to it, there's a problem there. And that's because this is not running. So I'm going to go ahead and start this again. And I started by doing run user interface. So if I do run user interface, then it is actually going to start. There will be a new window that pops up here. It will either pop up here. Yeah, it's popping up here. You see it's pointing at localhost at port 3000. If you recall our Flask application, what port is it running on? It's currently running on port 5001. And so that's just another example of the fact that we have two web services that are running here. One of them is running on port 3001 is running on port 5001. So right now it's loading all of the JavaScript code. Once it's done that successfully, you can see down here that this is happy with what has happened. There's not going to be too much more. And lo and behold, we have our user interface back and alive and running again. So I've shown you how I ran this user interface. I actually didn't show you. I just started the Quokka server. The way that I run it is from server, and I do /run Quokka. The way that I did the user interface is gone because it does a clear screen, but I did from UI, I did a run-UI, and the way that from monitors I'm going to run this is I'm going to do /run monitors, and that's going to start my monitors going. If you look right here really quickly, you can see in my user interface when's the last update that I have of data from my monitors. Well, it's 11:44, 11:42. You can see it's 11:50. So I've been blabbing on for about 6 or 8 minutes here. I'm going to run my monitors, and you will see that my monitors are starting to go. My hosts are getting discovered, and what you will eventually see is that these that now say 43, if I keep blabbing long enough, then they will eventually begin to show that they are updated with newer data. Why don't I refresh this, and we'll see if anything has updated. Up there we see some 1051, so you can see some of these have updated already. That's the current minute, so that's good. And here's services, and services are usually the things that run the fastest, and you can see these are all at 11:50. So yeah, that is basically how I run this. I run the server, and I run the monitors, and I run the UI. If I was using workers for capturing packets, or for doing trace routes, or for doing on-demand port scanning that is more detailed than the port scan that you see in the host screen, then I would be needing to run workers, which I could do as well. So that's how I run everything, but let's not get too distracted. We're talking about this user interface and how I get information like this, and so that's what we're going to do next, is talk about the actual code that does that. So as we look at the code that I wrote, I want you to be aware of the code that I did not write. So did I write the code that provides the framework for doing this type of application that involves JavaScript and HTML and CSS? No, I did not. Did I write the code that provides the look and feel and the buttons and the fonts and the app bars and all the other stuff? No, I did not. Did I write the code that creates these graphs, these wonderful graphs that displays them? No, I did not. Did I write the code that creates the ability to have tables such as this, and to display things and to sort things and to do all kinds of fun stuff? No, I did not. I did write the code that gathers the data and that populates this, but just want you to be aware, we're not reinventing the wheel here. We are reusing table capabilities, and we are reusing graphing capabilities as well as just the general layout and grids and just the way that things work. So there's a whole lot of code that I did not write. In fact, if we were to go and look at my dashboard, and I'll explain how this code is structured in a minute, if I just look at the imports for my dashboard, you can see here I am importing React. That is not mine, that's React. Look at all of these things that are coming from Material UI. There's the grid, there's the theme, there's the MUI, there's the MUI theme, there's the CSS baseline. All of this stuff is coming from Material UI. If I look at my dashboard app, then you can see there's React, and there's also a bunch of Material UI stuff. If I were to go to one of these tables, then you will see again React Material UI. I'm using all of this stuff. Oh, and here's something else. I'm using this thing called Material Table. That is what is providing me the mechanism to do the table. And if I go over here to the function and the class that I created to display all of these graphs, you'll see I have React. So that's React. You see I have Material UI. And up here at the very top, I have all of these things are from React-VIS. Not sure what that stands for. Visualize, maybe, and I'm not sure the right way to pronounce it, but that comes from Uber. And in fact, if you want to know more about these, well, how did I create the thing to begin with? I started by doing this Create React app, which if you go down to the very bottom of this, you can see that it was created by Facebook Incorporated. Material UI is something that Google has contributed, so this is where I can find out about Material UI. I mentioned Material Table. This is something that somebody wrote. I don't even know who this individual is, but it has nice tabular capabilities. And React VIS is something that you get from Uber. So if you were to go and look at more information about this, then you can see there's a community of folks that have contributed to it. And yeah, so that's where I ended up getting all of this stuff. I did kind of the background work to figure out what I thought would be useful. When you get to be a more experienced front-end developer, should you go down that path, you may be using Angular. There's a Material UI for Angular as well, but you may be using some different look and feel capabilities and a different tabular capability and a different visualization capability, whatever you choose. But just want you to know that there's a lot of code that you, or I in this case, do not have to write because it is provided for us by these wonderful frameworks that we're using. Okay, so let's take a high-level look at the code that implements this front end. You'll recall it is a React application. In order to create the structure that you see right here, not the stuff in components, but all of the other stuff, I used this script called Create React App. So you can follow this if you want to create one of your own. When you do that, you will automatically have an actual application. It doesn't do anything like what the Quokka Prime one does, but it will at least have a lot of the functionality in it. So that is where I got started by following that. Now looking at this, you'll recall, if you do remember the lesson on user interface stuff, that where everything starts is at index.js. That's the JavaScript file. And you will also recall that this is going to be a combination of JavaScript looking stuff as well as HTML looking stuff. Here you can see with these angle brackets, it looks like it's HTML. The thing inside is actually going to refer to a component that is written that is a JavaScript class. So just understanding the high level structure of this is going to refer to something that I created called dashboard. You can see it here in components. Everything, all the JavaScript code is under these components folder right here. Now I am running Visual Studio Code, so I'm not running PyCharm. Remember, when I do PyCharm, if I want to dive into the definition of something, then I do Control B. That's not the same in Visual Studio Code. For Visual Studio Code, you can see I could do F12, but I will just do this menu and go to the definition. Here you see I'm in dashboard. That's this file right here, this JavaScript file. And this is going to define the entire layout that you see here. So everything that you see, whether I'm displaying devices or hosts, or whether I'm diving down into doing any of these other things, or looking at graphs or whatever, this is going to be part of the whole thing is defined by the dashboard, and the dashboard has an application bar. That's this top thing, and then it has a bunch of components inside it depending on what it's displaying. And so this is some code that does that. We're not going to go into this in super detail right now. What I do want to do is the high level view. This is a class. Let's do a little bit of JavaScript learning here. You can see all of my import statements. This is stuff that I'm going to be using down here. I need to declare it up here so that the JavaScript compiler and the stuff that is actually trying to understand what's going on knows what these things are when I'm talking about it. My dashboard thing is actually a class, so this is going to be an object. When we extend or inherit from a particular base class, then we use the extends keyword, and the class that I'm inheriting or extending is called component. So as you can see, with everything that we look at in here, everything is going to be a component. So I'm going to go at a high level over this. Render is the function that is defined, or the member that is within my class, and this is what's going to get called when the user interface wants to actually draw what's on the screen. And as you can imagine, depending on what button has been clicked, it's going to try to render something different. And as you might expect, just ignoring this for a minute, coming down here, here is my if statement, and at a super high level, just thinking of this as pseudocode, if I'm going to be showing devices, you might think that that's probably what's happening in this device table screen, and you'd be correct. Then I'm going to create, set my info equal to this particular component, which is devices. If it's hosts, it will be this. If it's host status, it will be the host status. It will be the host status component that we create. If it's server status, it will be the server status component that we create. So it's all pretty simple. And then what we're going to do is we're going to return, and this is going to look like HTML, except that what's in here is going to be stuff that I have defined. So one of the things that I have defined in the angle brackets is dashboard app bar. Remember, this is basically the same as what we saw in index, where we have the angle brackets here, and I'm defining my component, and that tag is going to refer to the thing that we are actually going to be displaying. So the first thing is a dashboard app bar. The next thing is going to be these grids. Grids are part of the functionality that comes with the Material UI that is provided by Google. So I am going to create a container, and inside it I'm going to put this thing called info. If you see things in here that have curly braces, that's going to be just single curly braces. This is going to be an indication that it is a variable and it's referring to some JavaScript thing, and this is the JavaScript thing that it will be referring to. Whatever I set effectively my component that I'm going to be using to, that is what this is going to be. So if the user clicked on devices or hosts or services button, or if I'm doing host status, then it will try to display that. So that is just a general overview of the top level screen. Next, I want to go into a little bit of JavaScript functionality and how the JavaScript language actually works, how it's a little bit different than what you may be used to, which is Python. Okay, so let's look at some of the JavaScript as a language things. I think these import statements are fairly straightforward. Let's look at the class definition. I mentioned this before, but remember in Python, when we inherited from a base class, we put it in parentheses. In JavaScript, we use the extends keyword in order to identify the base class that we're going to inherit from. In Python, we use underscore underscore init underscore underscore for our constructor. In JavaScript, we call the thing constructor, and this is what will get called when this when an object of this class is created. So that is a difference. Another thing that's different is whenever we have a method or a function, we use the def keyword in front of it. You don't see that here in JavaScript. That is unnecessary. In Python, indentation is super critical, and you've got to follow indentation for every statement within a code block. In JavaScript, what we use instead is we use curly brackets. You'll see this in the language C, C++, Java, and others. And Python is just different in the way that it does things. So indentation doesn't really matter. I can indent to a different level. Now your IDE might complain and say, hey, this could be confusing if you do this. Please stop it, and you may have to correct it. But syntactically, it will compile and run perfectly fine no matter how you indent things, or if you don't indent things at all. You could have everything in this file on exactly the same line. So you see you have parameters that get passed, the same thing as in Python, so that's pretty straightforward. Here we have an if statement. Our if statement, of course, we're going to have brackets, and so we're not using indentation. This is true throughout the language, so you just need to get used to it. Your if statement needs to be inside parentheses, so that's something that's different. There's this relational operator that is, I don't know if other languages actually have this, but it is in JavaScript, and what it means is that not only are these values equal, but these two items are identical in the sense that they are exactly the same type. And so it does a more deeper comparison, and so you'll see a lot of times your IDE will complain if you're just using 2, and so you see 3 quite often. If you recall, in Python, you would use, if you're doing else if, you would do elif. There is no elif keyword in JavaScript. You need to spell out else if. And oh yeah, here's an important thing. In Python, you don't put a semicolon at the end of your statements. It's perfectly fine to not have any semicolons at the end of your statements. In JavaScript, it used to be completely mandatory. As I look up here, you'll see I'm kind of sloppy, and I did it sometimes and I didn't do it other times. It turns out in certain situations, JavaScript is perfectly okay without a semicolon. And those of us that go way back in our software development, we used to get compile errors all the time that would tell us you forgot to put a semicolon at the end of your line, at the end of your statement. And we would complain that if it knew that I needed a semicolon there, why didn't it just add it? So apparently we were listened to, and sometimes in JavaScript you don't need that semicolon, but just beware that it's probably better to get in the habit of putting it everywhere that is the end of a statement, like I'm seeing this in a number of different situations. Obviously, it doesn't really cause an issue in most cases. Last thing I want to point out here, you have a return statement. What are we returning? This is an example, as I mentioned before. We're actually returning not so much a variable as we're returning HTML. Actually, it's a combination of HTML and references to these things like dashboard, app bar. We're passing in info, which is something that we set in JavaScript. And so this is all part of the framework, and every framework will potentially be different, so you need to be aware of that. But just be cognizant of the fact that this isn't pure JavaScript. This is the JavaScript, they call it JSX in the React world, and that is their terminology for stuff that is a combination of JavaScript extended JavaScript, I guess, JavaScript and HTML. I wanted to show you hosts here. This is the hosts table, and this has a lot of stuff in it. As you can see, I'm setting a lot of variables here. You'll notice that when you have a dictionary in JavaScript, you're not going to have square brackets with quotes and the actual key or even a variable name for the key. But in general, what you end up doing is you use dot notation to refer to things of this nature. So down below, I would be referring to hosts as this dot states dot hosts. So be aware of that as well when you're dealing with things like this. Here you see a number of functions, and that's all good. One that you need to be aware of that's kind of different, and it will be difficult for you to wrap your head around at first, is this. And this is a type of software that is different from what we've done in Python, although we've done async IO. But the general idea here in what we're doing with this fetch statement is going to be an asynchronous request. What that means is we are going to go and do this piece of IO and make this fetch request. Fetch is a function that is defined within JavaScript. And so it's going to do a fetch, and then at some point later in time, it's going to complete. So what will happen in this code is that when the fetch is done, this code is actually going to return and go back to doing other stuff in this class called hosts. So if things need to get painted and updated, etc., in other words, it is not going to block. It's going to asynchronously return. And then at some point in time, when that fetch request has been completed, what is going to happen? Then, this is the keyword here. Basically, it's not a keyword, but it is a method that's going to get called when the fetch completes. And so you'll see these things called .then, and it actually is doing stuff kind of like what it seems like it's doing. It's waiting until this asynchronous thing is completed, and it is going to take the JSON. In this case, it will be the host data that was returned from our REST request. This is my REST request to our Flask Quokka application, Quokka server application. We're going to take this data and get the JSON portion of it, and then we're going to use that data and we're going to log it. We're going to set it equal to set the state of this variable, our state variable called hosts, which we referenced earlier. We're going to set data equal to that, and now I'm doing this countdown value. I can't go into all of this code. It would take many more lessons than this is, but I just want you to get a flavor of what is going on. And as you can see down here, this looks like a catch statement when we have try except in Python. Here we have a catch statement, and that says if an error is encountered, I want you to log it, and then I want you to set your countdown value equal to the original value, whatever it is. 60 seconds is the typical value. So this is showing you a little bit of this functionality. That is the table. Next, I'll explain to you about actually how we display the table, and then we will look at the actual graphs. Okay, let's talk about how the table gets rendered. That's this thing right here. How do we display tables, whether it's devices or hosts or services? What does the code look like? Here we are in hosts, and this is the return statement for our render function. So we are going to return, and remember, this is going to be a combination of HTML and JavaScript type stuff. It's mainly components, and embedded in them is going to be some JavaScript stuff. So let's take a look at it. Really what I want to go over mostly, here you can see host table and time until refresh, and you can see that on this output right here. I have time until refresh. I have a button that says refresh host that caused that to happen. You can see those three things are defined right here. This is the top most grid. What's directly below it, in other words, let me make this a little bit skinnier so that you can see. So what this table below it, it's actually a little bit different color, is going to be this thing here called material table. And remember I mentioned that material table was one of the things that I am utilizing in order to put stuff out in a material world, and that is this material table component. So here's my component called material table, and this is basically how the person who created it designed it. You will specify the title and discovered host with availability. That's what it says right there. Here you see another item that's going to go in here is going to be columns. And so as you might expect, I will be defining in this list all of the columns. There will be a column called status. That's a little bit special because I'm printing out an actual icon that will be red or green. There will be something called host name, and I have the ability to do a custom sort because I want to sort not based on the normal way that the material table does, but I need to make it case insensitive. Then I have a field called IP address, and I specify where in the data that's going to come from. These are actually referring to pieces of data that come from my Quokka server. Now you'll notice that in the world of JavaScript, we do camel case, so we don't do underscores, but this data that has keys associated with it comes from the Python world, and I'm not changing the name of these things at all. I'm just leaving them as they are when I get them, and so we're using this snake case way of describing these fields exactly as it is in Python. And so that's referring to those. And of course, up here under host name, I'm going to be referring to the field host name. And for my status, that's referring to the field that is actually availability. So now that is the actual columns. That's defining what is actually at the top here of the table. Now we want to say, well, where's the data going to come from? Well, the data comes from my hosts table. And so all this is doing is this object.values. I get it in the form of a number of dictionary items. I want to get rid of those dictionary items and get just the values. Do you recall in Python how with the dictionary you can say .values and it just gets the values and ignores the keys? That's what object.values is doing here. And host, that's what I got back from my fetch request. If I go back up here to where it says fetch hosts, you remember I'm getting the data that I get back. That is the data from the JSON. Then I am using that and setting it as hosts. So hosts is pointing at that. So that is what this is referring to. That's just all my data. If I have one row, if I have, as you can see over here, it's different for devices versus hosts. But if I have two rows, if I have however many this is, let's take a look, see if I can make this bigger. Actually, I only have 10 of those for hosts. What do I have? Something like 23. So I have 23 of these. So it will provide data for all of those. Now there's other things that I can define here. There are some options that I can give. So I'm having the padding be dense. I am specifying the initial page size. I'm specifying the row style here, and I want to set the color equal to red or yellow or chartreuse depending on different parameters that I care about, like availability or open TCP ports or not. And down here under actions, these are actually the things that become my buttons over here. So This is my button that is the time series. The icon, this comes from Google's icons. So that is a polling icon. It really refers to status for me, so you don't have to worry about what this is. The icon called policy rounded icon, that is this thing. And then let's see, this is the page view one. So those are the three, and basically what I'm doing here, this is following material table, is I'm saying if somebody clicks on this, then I want to take this row data and I want you to call render host status. And basically what that's going to do, when I look at render host status, it's going to set my dashboard. I have a reference to my original dashboard, that's this thing. I have a reference to it, and I'm going to set its state so that it changes. And I'm going to say, I want you to show host status. And I'm passing in a parameter called of name with the value of host name. When we come back to the dashboard, it will get awoken and it will say, what is show equal to? Show is equal to host status, and it's going to say host name equals the name that I passed in. And that's how this magic happens. When I click on this, it actually causes the new data to get, the new screen to get rendered inside here. So that is the table and how the tables work. Okay, let's discuss how we end up creating this screen right here. So basically, I'm at the host table screen that's showing all the hosts. This will be the same for devices and services as well. I'll just do hosts because I'm here and it's usually simpler. I'm going to click on display time series data, and this is going to print these nice graphs. Now we've explained how everything in our front end implementation is based on these components because that's how React works. And of course I will have a component called host status. How did I get here? I got here from the dashboard. If you recall, the dashboard is kind of the focal point for putting up the appropriate screens. And if somebody clicked on host status, as we've seen from the tabular screen for hosts, if somebody clicked on the status button, then we end up here and we bring up host status. And so host status, what does that look like? Well, here I'm going to come and show all of my open editors, and I'm going to load up host status. So this is what we're looking at. This is the component that is going to render this screen that you see right here. So let's take a look and see what it is. It's pretty much the same as all the others. You have host status, and it's a component, of course. Here's my initialization of these variables. I have my countdown. And down here, probably the most important thing to stop at would be my fetch host status data. Remember, I have fetch hosts in my tabular, my host table. Here I have fetch host status data, which gets called by my code at periodic intervals in order to, at the beginning with component did mount and my countdown timer. When we do the countdown gets down to 0, we go and call this this method. What is this method like? Well, it's pretty much the same as hosts or devices or any of the others. The difference is the URL that I create is a little bit more interesting. What it has is I am calling into my Quokka server. This is going to be /host/status. You'll recall that from our Quokka server Flask application. That's one of the endpoints, and it's going to expect a couple of parameters. One is the host name. If any of you are familiar with what I did in Quokka, the original implementation, I was passing in the host identifier, so the ID. In this situation, in this implementation of my Quokka Prime, I'm using host name as the key, and so we're passing in the host name, and then I'm also specifying the number of data points, and this stuff comes from my env file, the .env file that gets read when my React application gets loaded. And then once again, remember, we're doing asynchronous requests, so I'm going to send out this request, and then it returns, and at some point in time when it completes, I'm going to get the JSON data. That data is going to be logged, and then I'm going to set my host data for that particular state, and then I'm going to reset my countdown value. So I take the data, and then I reset the countdown value. Now, what does render look like? Let's see what that actually looks like. It's pretty simple for doing all of this stuff. Why is it simple? The reason that it's simple is because I'm actually going to be calling this status graphs grid component in order to do all the graphs. So we don't have to worry about that right at this moment, because look here, this is using my material UI grid like I do everywhere, and basically I'm going to have a grid item on the left. You can see that over here on my screen. What am I going to have? Host name, that matches what you see over here with this host name. Shouldn't have clicked on that. My IP address, you can see over here is the IP address. I have the MAC address and the last heard, and then the refresh in, and that's actually not going to be a fixed value, but it's going to be repainting. You can see it's refreshing in, and the seconds is actually counting down. The last item is a button, and that is a button that will tell me to return to the host screen. That will go back to my host table, and this is how we handle that. And then for all of the graphs, basically I'm calling this entire area, what you see here with these 4 graphs, that is going to be handled by this component. Now, why did I do it in a component? I did it in a component that is common because when I go to devices and I do this, this part here is going to be the same. You see the thing on the left is actually going to be different depending on whether it's a host or whether it is a service. If I come over here and look at a service, you can see I have target data information here. But this information that you see right here, this is going to be consistent for all of the different device host services. So that's why we are reusing that particular component. And the code that I do here in status graphs grid is going to be what prints out those graphs. So I'm going to right click and I'm going to say go to definition. That will open up my status graphs grid, and we can take a look at what this is. Again, it's a component. Again, we have the render function that is going to do stuff, and there's a lot of stuff in here. I'm not going to be able to go over this point by point. The important thing for you to be aware of is that I've done I've done my REST API call in order to get the data that I'm printing out. So I have that data. I'm going to be manipulating it somewhat in order to get it in a format that if I go up here, then you can see React-Viz. That is where I'm getting all of these things that contribute to the graphs that I am printing out. And so I need to get it into a format that's appropriate for that. And that's what I'm doing right here. I even have a common function called getStatusData, which will get called, and I will I will manipulate the data to get it into a format that I need for printing stuff out. Now, the stuff that you see here, it would take me a very long time to give you a tutorial on, number one, all of the grid functionality that gives me the grid layout that you see here. So I'm not going to go into that. If you decide to get into Material UI and React, etc., you'll need to read up on that. I will tell you that there was a lot of experimentation and trial and error in order to get this to work. The important thing, though, down here I have line series for my response time that you can see. Let me shrink this a little bit, and I'm going to make this go away. So over here you see response time, and then you also see our response time summaries. The way that I print out response time is I'm using something that in my React-Viz is called the line series. The whole thing right here is called a flexible XY plot. And you'll see that I use a flexible XY plot for response time as well as for availability. Flexible XY plot, you will notice here, that is up here, I'm using line series, and down here I'm using line mark series. And this is not JavaScript. This is React and Material UI and React Vis. But it's what they've created called line mark series. You can see it has the dots in it, which makes it a little bit more fun for availability. It would have been really boring because availability quite often is 100%. I decided to put these dots on there. Now I specify my data by passing in the data associated with this keyword, and then I set a style to have the stroke width of 3. That makes this thicker. When it was using the default, I found it to be a little bit hard to read, so I made it quite thick. And down here it's the same thing for a line mark series. Here's the data that I'm passing in. I specify the color to be green just because I wanted it to be different, and then I also have a stroke width. And as you will not be too surprised, I have one flexible XY plot, 2 of them, 3 of them. This is where I'm getting into the summary data for response time, and here is my last flexible XY plot, and that is for availability down here on the right. Now, whenever I get new data, it changes this, and it causes things to get updated. So you've seen every minute or so, or when I click on the refresh button, which has gotten, I actually don't have a refresh button here, do I? That may be something I want to add. I may want to look into doing that. But it refreshes now, you can see, in 21 seconds, and what you will see probably is that this graph over here will change because these are getting updated every minute, and as you may be aware, if I've mentioned it, I'm getting new data about every minute. Let's see if this changes. It did change. So you can see that that changed. It is not at the top of the hour, so I don't have new hourly data, but as you can imagine, every hour this graph over here on the right will change as well. And that's how we do it. Let me put this back up here, and I will make this a little bit more readable. As you recall, where we went from our index, and from our index we went to the dashboard, and the dashboard I don't see here, so let me do this and say go to definition of dashboard. Dashboard is the thing that pops up a different display every time I click on a button to do something different. For example, if I click on return to host, that's going to go through my dashboard, and it's going to do this hosts thing here. And each of these is a component that I've created, and I have hosts, I have services. This is my services table. You can see that, let's see, I have trace route there. Here's where I fetch services. Again, asynchronous call to get services. Here's my URL. I didn't go over that probably before in great detail. I'm just getting all the services, and if I was looking at services here, then this would be what we would be getting and observing in that regard. When I do decide that I want to drill down and go to something a little bit more interesting, let's go to David Bomble's site here. You can see response time is pretty common, pretty consistent there. When somebody does end up, remember, clicking on one of these actions, the display time series for the services, that's when I didn't really go through this, but I have a function called render render service status that is defined within my services. Render service status is where, again, I'm tweaking the dashboard state to say I want you to display service status, and that goes back to the dashboard, and then it brings up the service status screen, which is similar to the host screen like we've seen here before. We're going to fetch the data. This is the same as the host URL, except it's for services. We're going to get that data, We're going to print the stuff up on the left, the target data if there is any, and then we're going to do this status graphs grid. Status graphs grid component, when it prints, is going to have all of this reactivist, flexible XY plot stuff with all of these different parameters. So that is my pretty high level description of what this is doing and how it works. I'm hoping that it makes sense. Let's review what we talked about. Okay, so let's review all of what we talked about in this lesson, and there was a lot of stuff that we talked about. We reviewed the user interface, how you have these tables that get printed, and that this whole framework for user interface front end stuff is being leveraged from Facebook's React and from Google's Material UI and from some extra libraries, one for doing table and one for doing this stuff that we're looking at here, doing graphs. The graphs is called Reactivist. That came from Uber, and the table came from somebody who did something called Material Table. So we wanted to look at the code that accomplishes this. Now our code we reviewed because we've gone over this before. At the highest level, we have something called index, which is going to refer to our thing called dashboard. When I right click, I can go to the dashboard. You can see there's some JavaScript stuff here. So now it becomes interesting from a JavaScript perspective as well as from a front end perspective. So I'm importing things. That's pretty straightforward. The idea of using a class here, that is something that we've done in Python, but when we inherit from a base class, we use the extends keyword. Some things to be aware of: indentation doesn't matter. We're using these curly brackets to do that. We're going to reference items in a dictionary or an object, something like a Python dictionary, by using dot notation. So we will continue to see that throughout this code. Here is the code that is in the user interface model and framework from React. We're going to be doing a render, and this will be a combination, as you can see down here, of HTML as well as JavaScript. So it kind of mixes these things together. This is framework specific, but you can see there's some JavaScript stuff in here. You can see my if statements. That's probably not too different from what you're familiar with if you're familiar with Python, although we don't have elif, we just have to explicitly state else if. You'll notice something a little bit quirky looking. This 3 equal sign is something that we use to specify not only do the values have to be equal, but the types have to be equal as well. And we will be returning information that is going to be HTML-like, but it may reference things that we created from our JavaScript. Like here, I set info. You can see it's nicely highlighted, and we're actually filling this HTML stuff with that information. And that information could be a devices or hosts or services table, or it could be a host status, service status, or device status. That would be what is getting printed here when I display this entire graphical stuff. And so looking down at, let's say we're going to go to hosts just for kicks. My host definition, here's my host component, and one of the things that we continue to mention is this thing called fetch hosts, which I call periodically. We're going to do our request to the Quokka Prime server and web service that's running on our port, which is actually port 5001 in our situation. So we're making a request. I do want to go back and just reiterate here that when we're talking about what is actually going on, there are 2 web services. One of them provides the framework, in other words, the skeleton of all of this, and then one, and that is what the Node.js, the npm start stuff does, and all of this React framework, as well as Material UI, all the HTML that goes back, that's that thing. But then there's the data, and the data that goes into the graphs, and the data that goes into the actual tables here that you see. that is coming from this REST server. Okay, let's go back here and let me pop up one of these just so that we have that available. What we're looking at, here's our request that goes down to our Quokka server. Remember, this is going to be an asynchronous request, so it's going to make this request and then it's going to return control to the rest of the program. We're not going to sit here and block everybody else and wait. Rather, we're returning control. That's how things work in the front end. And this .then method is going to get invoked when we get data back. So we're going to take the data, the JSON data, we're going to set it, in this case, to hosts. And then when we get down here and we look at the table, we've been through this a little bit before, but the material table has columns. That's what the different columns in the table are going to be. And here is my data that's going to get printed out. Then once somebody actually goes and chooses one of these actions, that would be over here on hosts when somebody clicks on this button that we were just looking at. Where was I looking? When somebody does that, that's when we are going to render the host status. Host status, what we're looking at, which always seems to go away when I want it. So I'm going to come and I'm going to go to render host status. Let's find that, render host status. It's going to pull up, it's going to set my dashboard. The dashboard, I go back here and I find host status. What's it going to be doing? If it's host status, I'm going to be creating this component called host status. That is where we come in here and we looked at this, the host status, the screen itself. Oh, by the way, don't forget about this. This is where I get my data. This is the URL, a little bit more complicated. This is my fetch request. This is making the request to the Quokka service. Now down here in render is pretty simple. All I'm really doing is, see this host name, IP address, MAC address, last heard? That's exactly what you see over there. And then the important and interesting stuff are these graphs. Where does that come in? Well, that's implemented in this code right here, my status graphs grid. If I go to that, then this is where we see all of our React Vis stuff coming in. We have flexible XY plot, horizontal grid lines, line mark series, line series, etc. And so here you get to see me setting up the grids so that I have these 4 different locations for my different graphs, and then using flexible XY plot in order to do all of those plots that you see over there on the right. And if I get rid of this and make this a little bit easier to see, then you can see that I am doing 4 of these flexible XY plots. The actual data is getting put into a line series. This is my data that I passed in and that I manipulated. That's my response time. Here's my availability. Here's my response time summary. That's this part on the right. And this is my availability summary. And that is my attempt at a quick summary, which I see took over 8 minutes. My apologies. There is a whole lot of stuff here. This is a long lesson. Thank you so much for listening. As always, if you do have questions, please let me know. Thanks for watching and listening.